So, as you know, normally when you are surfing the web, you've got your client. This is your computer, and on your client you have your web browser, a program like Internet Explorer or Firefox or Chrome or Safari, something like that. So on your browser, you put in a URL, http://www.cheese.com. Second best website on the internet. All right, so you put in this URL, and it goes through the process of DNS to figure out what IP address is associated with this URL. And let's assume that the IP address associated with this URL is this server someplace else on the internet, right? So your request is going to use the HTTP protocol, Hypertext Transfer Protocol, and it's going to send a request for a web page to your local switch, and it's going to send it to your router because it's the default gateway and the exit out of your network. Then it's going to go over telecommunication lines to your internet service provider. It's going to go out into the internet, and in the internet it's going to bounce all over the place. In fact, the individual packets, data packets from the request are going to take separate pathways, each finding their own way to the destination internet service provider. And then they'll take telecommunication lines to the web host router, where they'll get forwarded to the switch to the server. And then the server will respond to those HTTP request packets, and it will find the files that you requested, and it will send them back to the switch, back to the router, back to the destination ISP, which is now the sending ISP, bounces its way through the internet in various pathways, and then comes back to your ISP, to your router, to your switch, to your client. And now your browser can do the job of interpreting the HTML code it just downloaded and draw the web page on the screen. Right? So this is normal web development, or normal web, browsing, basically. And this is the way it's been since 1994 when the first web browser was created. However, bad guys came along, and we started to become worried about bad guys getting a hold of information during this transaction that they might be able to use. Let's say, for instance, you're shopping for cheese on cheese.com, and you filled up your basket and you're ready to make your purchase. So you go to the checkout and you enter your credit card number. So when you put your credit card number into the online form onto the web page and you hit submit, your credit card number takes that path through the internet to the destination, where the server can grab your number and then do what it's programmed to do, process a transaction most likely. So now we've got sensitive information like a credit card number, and we might feel okay with it on our computer or in our local area network. We might even trust the web host and the server for the company that we're doing business with. But our data is also floating around the internet, each packet taking a different pathway. And somewhere in there, we might start to be a little bit worried about who else is out there. It's very possible that we might have a bad guy out here on the internet someplace. He could be here in your local area network. He could be at the destination. He could be at the ISP. But somewhere on the internet, this guy could be listening to the data packets as they come across and bounce around the internet. Now, he's not necessarily interfering with them. You might make your transaction and your credit card number goes through the internet just fine and makes it to the destination. However, as it comes past him, he's just listening in. And when he hears your credit card number, he writes it down. And then who knows what happens to it. He might use it to make purchases with your credit card. He might use it for identity theft, to open other accounts, credit accounts, or who knows what. One thing that's fairly common on the internet, unfortunately, is that he simply takes your credit card number and he puts it on a list and then sells the list to multiple bad guys on the internet who could do all kinds of things with it. So this is one of the dangers, is you got a bad guy on the internet listening for your credit card number. So what do we do about that? Well, you probably know that whenever you're going to send your credit card number or any kind of sensitive information across the internet, you always want to make sure that the URL on your client browser does not say http://. Instead, it should say HTTPS, right? And if you recall that this S stands for secure. And what it means is that before sending sensitive data over the internet, your browser on your client computer is going to scramble that data. It's called encryption. And so it takes that data and it scrambles it, and it sends the scrambled code through the internet. And when the scrambled code gets to the server has the decryption key, which allows them to decrypt your data and be able to make sense of it. But if there's any bad guy out there on the internet who is listening to the data as it comes by, what they hear is scrambled, garbled data. And if they don't have the decryption key, they can't unscramble it. It can't be reverse engineered. They cannot unscramble it, so all they've heard is a garbled mess. All right. So that HTTPS is fairly critical. Let's take a closer look at how this works, and we'll also uncover some other dangers that are also protected against, right? So let's put this bad guy away for a sec. Okay, whenever you're going to do some kind of sensitive transaction over the internet, what you want to do is open a session between the client and the server. This is a session where the client and the server agree upon how the encryption is going to work and use the encryption until the session has expired. So the first thing that happens during this session is that there's what's called a three-way handshake, a communication between client and server where they establish what's going to happen during the session. Okay, so bear with me as I draw it out here. The switch has nothing to do with it. It was just in the proximity. Okay, so let's pretend that this client is talking directly to the server, and I'll make my arrow a little bit thicker here. Wait. All right. So the client's talking to the server. This is the first part of the three-way handshake. And what the client says to the server is, text box, he says, let's communicate over TLS, not X, S. TLS is transport. You know what? I'm going to write this elsewhere because I'm going to run out of room right here. Let's communicate over TLS, and we'll just throw up another text box someplace. Looking for my text boxes. Insert text box. Okay, just as a side note up here, TLS stands for Transport Layer Security. If you're familiar with the OSI model, the Open System Interconnection model, which is the fundamental blueprint for computer networking, the transport layer is the layer that's in charge of flow control. It's in charge of paying attention to each and every data packet called a segment at this layer and making sure that it arrives and it gets put back in place and that it gets tagged with the appropriate protocols, etc., etc., etc. So this client is saying to the server, let's communicate over TLS. Now, TLS does not provide the security. TLS provides a mechanism for the encryption to occur. So part of what happens in this opening part of the three-way handshake is that the client says to the server, here are the cipher suites I know. Okay, what's that all about? Well, when communication gets encrypted, okay, just trying to get this. All right, that's fine. Okay, when communication gets encrypted, what happens is the client is going to scramble it in a certain way, and the way they're going to scramble it needs to be understood by the server, by the intended destination, so that they know how to unscramble it once they receive it. So basically, this client is saying to the server, these are the different ways I know how to do encryption. Okay, Now, the server is going to respond to this communication. Just bump this up a little bit. Maybe we'll get this word out of the way. Making some space on the page here. Okay. So now the server is going to respond back to the client, and use this bigger thing here. And what they're going to say to them is, I choose a cipher suite. Here's my digital certificate. Okay, we'll put this over here. Okay, so of the cipher suites that the client has offered, the server has chosen one that they also know how to do. They say, oh, you know this method, you know XYZ method, so do I. Let's use that method. Okay? But the other part of this communication back is that the server has provided its digital certificate. All right, so let's talk about what that's all about. One of the other fears, in addition to the guy who's just listening for the data to go past, one of the other fears is that somebody will not only be listening, some bad guy, oops, didn't mean to move the whole internet, some bad guy on the internet is not only listening to this communication, but they are attempting to pretend that they are the destination so that you'll tell them all their secrets. Okay, this is called a man-in-the-middle attack. So here's a bad guy, and this bad guy says, oh, that text is not staying in that bubble. All right, this bad guy says, I'm cheese.com. Remember we're trying to get to cheese.com? He says, I'm cheese.com. Give me your sensitive data. Okay, so essentially, this bad guy is pretending to be this destination, right? And if he was able to fool you, then instead of doing this TLS scenario between the client and the server, you would initiate this whole TLS process between you, the client, and the bad guy, thinking the bad guy was the server. And so to keep this from happening, this man-in-the-middle attack, in fact, we should label this insert text box. Not in the missile. That'd be a whole different kind of attack. All right, so in order to avoid this man-in-the-middle attack, we use this thing called digital certificates. So what happens with digital certificates is that there are entities out on the internet called certificating authorities. And so let's see if we can just throw in a shape here. What shape could we use? This one looks like a house. Okay, we'll put it over here, and we can make it see-through. Maybe not blue, maybe pink. Okay, so this is a certificating authority, or CA. Okay, so a certificating authority, or CA, this is a company or an organization that exists on the internet, and their job is to be the proof of identity. Okay, so if I want to set up a website, when I create my host, when I get my host and I create my domain name, I'm going to submit to a certificating authority to ask for a digital certificate, and they're gonna issue a digital certificate, and they're going to keep a copy and put a copy on my server. All right, so in this situation down here with the TLS, let's get back to this real quick. The client said to the server, hey, let's communicate over TLS, here's the cipher suites I know, and the server said, here's a cipher, I choose your certain cipher suite, here's my digital certificate. Now, the client is going to do its due diligence, and it's not going to take the server's word that they are who they say they are. This server says I'm cheese.com. Yeah, well, you know what? So does this bad guy. So how do I know for sure you're cheese.com? So what the client does is they send a message to the certificating authority and they say, hey, this guy says that he's cheese.com. Could I please have a copy of their certificate? And this guy said, this certificating authority says, yep, here's a certificate. And now your client compares the certificate from the server to a copy of the certificate from the certificating authority to see if the two certificates match. If they match, then this guy's telling the truth. If they don't match, if the bad guy either can't come up with a certificate or comes up with a false certificate, then the client says, nope, you are not who you pretend to be. You get a browser warning that says certificates don't match. This could be a bad situation. All right, so that's what the digital certificate would do for you. Okay, so now that the client is satisfied, let me just move this text out of the way here. Now that this client is satisfied that the server is who they say they are, and that we have fended off this man-in-the-middle attack, right? Now the client is going to finish the three-way handshake, and they're going to communicate one more time back to the server. And let's be consistent with our lines here. Okay, and in this third communication attempt, this third part of the communication attempt, they're going to say, well, what they do, all right, so with this digital certificate that the server has sent to the client, part of the digital certificate includes what's called a public key, a public encryption key. And basically, the server has got this public key, this encryption hash that it shares with everybody. It's public, it shares with everybody in the world. So as part of this digital certificate, it shared it with the client. Now the client is going to use that public key, and it is going to encrypt some data, and it's going to send a randomly generated encryption. What do you call this? This is called, well, it's an encryption key. But this particular encryption key, which I've spelled encryption wrong, has got a couple of names. One name that it's known by is a session key. Another name that it's known by is an ephemeral key. An ephemeral key. And so what this means is that this is a temporary key. This is a key that's going to be used for this session only. After this session, that key's gone. And if communication ever wants to happen again, you're going to have to do the handshake all over again. So it sends this random encryption key, and remember that this random encryption key is based on the server's own public key. And so the server now is going to use its private key to decrypt it. And now, once that's happened, then the session, well, we'll say an encrypted session, okay, pulse. An encryption session can take place, and this encryption session could take any amount of time. It could just keep going and going and going, right? But once this session is closed, and it could be closed on purpose, hey, we're done talking, hang up. Or, ooh, I should have put this above, not below. Or it could time out. If one part or the other doesn't talk for long enough, then it could time out. But once the session ends, okay, then anytime communication is going to resume, it would start over. And this whole process would happen all over again. And so the next time through, the client would create a different randomly created encryption key, session key, right? So that temporariness, that ephemeral state is important, because that means that some bad guy couldn't grab that session key and use it, right? If they got a hold of the session key, well, guess what? It's only good for this session. And so you can't use it outside of the session. Even with the same server and the same client, you can't use it again in this session. So, this isn't covering all of the little details. Certainly didn't get into public and private keys very well, but this is the gist of what happens. Now, a couple of important pieces that you need to know. TLS, Transport Layer Security. This is a grown-up version of another protocol or another method called SSL, which was Secure Socket Layer. Okay, so SSL, Secure Socket Layer, was around for a good long time, and it's basically the same process. This TLS process is an improvement on it, right? SSL, they updated a couple times. I think it got to SSL 3, and then instead of upgrading it again, they changed it over from SSL to TLS. So the current standard is TLS. However, the language of the scenario is steeped in SSL. And so a lot of times, if you're out on the web looking for something like a digital certificate, you'll hear it referred to as an SSL certificate. Also, sometimes when you see TLS, you'll see it listed TLS/SSL, okay, or even just SSL. So just know that when you see SSL, you're looking at the same concept, right? It's TLS is just the upgraded version. All right, before we move on, let's just hit it one more time. Well, actually, let's look at it from the opposite point of view, right? So in this class, we've been thinking about, well, we want to be a web developer. We want to create websites. All right, so we know that once we write the HTML or the HTML and the CSS and the JavaScript and all the different components of our web page, we're going to post it to a publicly accessible web server. All right, so if we post it to a publicly accessible web server, we want our protocol that automatically comes up on the client browsers, we want it to be HTTPS. These days, it's almost the default. If you're talking to a server and it doesn't come up HTTPS, a lot of browsers even mark it like not safe or not secure. They'll flag it so that it shows up on your screen that way. So it's become the exception, or the rule rather than the exception to the rule, that you have a secure connection. So you want to have a secure connection. So if I'm going to post my web page or website to a server, whether it's my own server or a web host that I've rented space on, and I want to use the HTTPS protocol, what do I need to do? Well, a lot of times when you rent space on your host, and or if you register a domain name that you're going to use, either one of those services, a lot of times they're done by the same company, what they will do is they will initiate for you the process of getting a digital certificate from a certificating authority. For a long time, in my viewpoint, the most well-known certificating authority was a company called VeriSign, which stands for Verify Signature, VeriSign. But nowadays, there's one out there called Let's Encrypt. And you can just Google it. Google it, Let's Encrypt. And the nice thing about Let's Encrypt is that it's free. And so basically, your DNS provider or your host will send a message on your behalf to Let's Encrypt and say, can we please have a digital certificate? And then they'll take a copy of that digital certificate and put it on the server right along with your website in a way that the server service, the application layer service that provides the web hosting, it will interact with your digital certificate so that on behalf of your site, the server will respond to TLS requests for many clients that are out there. Okay, so the good news is that for the most part, this is a fairly seamless scenario. But the big thing is that you need to be aware that it's going on, because if you post a site to a server and then you test it the way you should, once you from the server, once you post it and you see that you're not getting HTTPS, you're seeing that it's not secure, now you need to get involved. You need to troubleshoot your digital certificate. You need to possibly contact your host. You need to maybe go through the steps listed at Let's Encrypt about how to make sure that your digital certificate is in place and working. So the biggest thing is be aware. Check your site, make sure it's secure, especially if you're going to take any sensitive information, credit card numbers, social security number, any kind of identifying information that somebody could use for identity theft. All right, I hope that all makes sense. If you have any questions, contact your instructor.